Good afternoon. Am I audible? Am I audible? Hello. Can you hear me? Suraj, am I audible? Suraj, am I audible?
Yes, sir.
Okay, fine. So only around 7 students are logged in. Anyway, I will continue the class. So now here, next problem on resultant of non-concurrent force system. So determine the resultant of a force system as shown in figure acting on a square plate that is 40 mm by 40 mm side square plate, and each grid is of size 10 millimeters by 10 millimeters. Determine the x and y intercept of the resultant. So we need to find the magnitude, direction, and the position of the resultant. Along with that, we need to find the x and y intercept of the resultant. Now this is the given figure. So it is a square laminar 40 millimeters by 40 millimeters, and each unit is 10 millimeters by 10 millimeters. And here the forces are acting. So let us call this point as say A, B, C, D, and at point A we have a 200 Newton force acting, and at point B it is subjected to a force of 250 Newton in the downward direction, and at point C you have a force of 150 Newton, and at point D you have a 100 Newton force as well as a 400 Newton force acting at point D. So it's a square laminar. Now here each square unit is 10 millimeters by 10 millimeters. Now we don't know these angles, correct? So the angle made by this 200 Newton force, so when it is directed upwards, so this angle you can call it as theta 2, and this angle as theta 1. So we don't know these angles, theta 1 and theta 2. So we can find this angle by using the tan relationship. So theta 1 is nothing but, so this height is 30 millimeters, and this is 10 millimeters. So tan theta is nothing but opposites by the adjacent side. So it is 3 by 1. So this height is 3 and this is 1. So thereby we'll get the value of theta 1. That is tan theta is equal to 3 by 1. Theta is tan inverse 3 by 1 is 3. So thereby we'll get the angle theta 1. So similarly you can find this angle also, theta 2. So now if I project this force, it is projected up to this point, and now this height is how much? It is 40 millimeters, 10 plus 10 plus 10 plus 10. So if you consider this triangle, so this becomes the opposite side and this is the adjacent side. So thereby you can find this angle theta 2. That is tan theta 2 is nothing but it is 4 by 2. So that is 2. Theta is tan inverse 2. So you will get these angles theta 1 and theta 2. So now first you have to find these unknown angles theta 1 and theta 2. Then you can select the reference axis, which right over here, x and y axis about point A, about which you require the magnitude, direction and position of the resultant, and also the x and y intercept of the resultant. Now let us see that the theta 1, correct? Tan theta 2 is, you can see here, tan theta 2 is 40 divided by 20. So you get theta 2, the value of theta 2 is 63.43. So tan theta 1 is 30 by 10. So theta 1 works out to be 71.57. So these are the corresponding angles, theta 1 and theta 2. Now, select the reference axis x and y. Next step is find the sigma f of x. So the forces which are parallel to the x-axis. Now let us start from this point. Now here, if you project this force, correct? So this angle, you know, theta 2. So it is in the first quadrant. It is in the first quadrant. So hence, the cos component is 200 cos theta 2. 200 cos theta 2. It is acting in the horizontal direction. So sigma f of x is. So please mute ಮಾಡ್ಕೊಳ್ಳಿ. ಕೆಲವೊಂದು unmute ಇದೆ. So please mute ಮಾಡ್ಕೊಳ್ಳಿ. So now theta 1, theta 2, you know, so find the sum of horizontal component sigma f of x, that is 200 cos theta 2, that is 63.43 plus 150. You see this is parallel to x-axis. So sigma f of x is 200 cos 63.43 plus 150 plus 100 plus 100. And this angle is theta 1, this angle is theta 1. So this is also theta 1, and this force is directed towards the fourth quadrant. So this angle is also theta 1. So it is 71.57. And if you resolve this force, its x component is 400 cos 71.57. So thereby you will get the value of sigma f of x as 200 cos 63.43 plus 150 plus 100 plus 400 cos 71.57. So now sigma f of y, that is 200 sine 63.43, 200 sine 63.43 minus 250, because this is acting vertically downwards, minus 250. And okay. So someone has raised the hand. Any problem? Hello? If you have any doubts or any problem, someone has raised the hand. I know who is there.
No, sir. No, sir.
Hello, pardon?
By miss it happens. Sorry, sir.
Okay, no issues. Okay, nothing to worry. Okay, we'll continue the problem. So sigma f of x and sigma f of y is 200 sine 63.43 minus 250 acting downwards. And if you resolve this force, its vertical component is minus 400 sine 71.57. Now let us see whether whatever the sigma f of x and sigma f of y we have done. So now you can see here, this is 150. He has taken this 150 plus, you can see 400 cos 71.57. So this force he has resolved, 400 cos 71.57 plus, you can see here, 200 cos 63.43 plus 100. So this one. So always better to move from one direction in the clockwise direction, so you will not get confused. So I cannot omit any other forces. So thereby you will get the value of sigma f of x as 465.916 Newton. Similarly, sigma f of y, let us check, minus 250 minus 400 sine 71.56 plus 200 sine 63.43. So it works out to be 450.588 Newton. So now you can see here sigma f of x is positive and sigma f of y is negative. So hence the resultant lies in the fourth quadrant, and you can find the magnitude of the resultant. R is 648.169 Newton, and also the direction of the resultant theta is tan inverse sigma f of y by sigma f of x. It happens to be 44.04. So don't consider this negative sign. You can keep it the positive value only. So 44.04. So the resultant acts in the fourth quadrant, since sigma f of x is positive and sigma f of y is negative, and the angle made by the resultant with respect to horizontal axis is 44.04 degree. So now we want to find the position of the resultant. Position of the resultant with respect to, say, let us find the position of the resultant with respect to point O. So let us consider this point as A. So sigma MA. So we can take the moment of all the forces with respect to this point. So now the horizontal component of this force is acting along x-axis, and it is in line with the horizontal axis, hence the perpendicular distance becomes 0. And the vertical component is also acting along y-axis, so I can neglect this force. And this force also 250 Newton, it is acting along the vertical axis and it coincides with point A, hence the perpendicular distance is 0. Now, for this force, so if you consider moment of all the forces with respect to this point, so 150 is acting like this, correct? And the perpendicular distance is 40 millimeters. So it creates a clockwise movement with respect to this point. So 150 into 40 millimeters. Next, so for this force, it is acting along x-axis, hence the perpendicular distance is 0. And the cos component of this force, 400 cos 71 point something 57 or 71.57. So it's also acting along the horizontal axis, hence the perpendicular distance is 0. And the vertical component of this 400 Newton force, that is 400 sine 71.57, and the perpendicular distance is 40 millimeters. So it also creates a clockwise movement. It also creates a clockwise movement. So suppose if you take the moment of all the forces, that is, you can see this force 150 Newton into 4, 150 Newton into 4, plus you can see 400 sine, that is the vertical component of this, 400 sine 71.56 into 4. So both creates a clockwise moment, hence the net moment value is about this 21,178.933 Newton millimeters. So you can convert it into meters also. So here you can take it as 0.1, 0.1. So then the calculation becomes simple. So you can either keep it in Newton millimeter or Newton meter. So you got the sum of the moments. Now you want the position of the resultant, that is the D. So the position of the resultant, you know the equation, R into D is equal to sigma MA. So you know the resultant value, that is 648.169 Newton. So if you divide sigma MA divided by the resultant value, you get the position of the resultant. Now in this problem, he has only asked about the x and y intercept of the resultant. So x intercept of the resultant, sigma M divided by sigma f of y, and y intercept of the resultant is sigma M divided by sigma f of x. Now these are the values of x intercept and y intercept. That is, this is the x intercept. It was sort of 47 point. I think there is some mistake here because it is beyond this, because this total length is 40 millimeters. Now you can see here this x intercept which cuts the resultant cuts the x-axis. It is beyond this point because it is 47 millimeter. It is somewhere here. It is somewhere here beyond this square, and the y-intercept is also 45.445. It is above this. So the resultant is somewhere like this. Okay. So don't worry. So whatever the values you get, you can write. So now next you have one more problem of the similar kind. Determine the position of the resultant of a force system if the external moment M, that is 3 Newton meter at the point P, that is 20, 10 as shown in figure. That means it is also a square plate and each side is 10 units or 10 millimeters or whatever it may be, 10 centimeters. So this is a square plate and each unit is either 1 by 1 or whatever it may be. Here he has given the coordinate, that is 20 and 10. Now at point P, so this is 20 and this is 10, correct? 20, 10, and you have an existing moment. You can see here an existing moment is acting at point P, and intensity is given. The magnitude of the moment is given. You can see 3 Newton meter. So it is already an existing moment. So now here, so let us consider this point as say A or O, or the origin of the coordinate axis, and this is 200 Newton force is acting at this point, and this angle is theta1, this angle is you can call it as theta2. So here also this is not theta1, theta2, and at point B, say 250 Newton is acting, and at point C 150 Newton is acting, and this is 100 Newton and 400. It's the same problem. The numericals are same. Only thing is here at point P, there is an existing moment of 3 Newton meter. That is only the difference, I hope. Right? All the other things are same. All the other things are same. The resultant value is also same. And theta is also same, 44.04 degree, and x-intercept. So here also the moment, so only the difference is in this problem, here somewhere this is point P, no moment, existing moment is there, but in this problem, you have an existing clockwise moment of 3 Newton meter. So while taking the moment of all the forces with respect to point O, so 150 into 40, 150 into 40 same, and for this component, vertical component, 400 sine 71.57 into 40 plus 3. You have to add this. You can see here. I think and here he has done a mistake. In the textbook itself, he has done a mistake. He has not considered that moment here, 3 Newton meter. It should have been taken here. The same value is 1178. So there will be some printing mistake in the textbook, so don't worry about it. Go with the basics. So you have to add this along with, I think if I add 3 here, it becomes, I think, 21, 1, 8, 1.487. So anyway, in the moment equation, along with this two forces moment, you have to add this value 3. So if it would have been like this in the anti-clockwise direction, then you have to take the negative value. This anti-clockwise moments are negative. So instead of plus, you have to take -3 because here it is creating a positive moment. So you have to consider this value. So all the other things are same in this problem. Now again, you have one more problem. Determine the magnitude and y-intercept of the resultant. So always read the questions properly because you can avoid some of the steps. Right? Here he has asked you to determine the magnitude. Only the magnitude and direction is also required. And y-intercept of the resultant of the force system acting on a lamina as shown in figure. Now let us see what it is. Now here this is also a square lamina. Each is 1 square unit. And here I think you have a, so let us select the reference axis right over here. And here you have a 400 Newton force. And here you have a 600 Newton force. So this angle is unknown to you, theta, you can find. So this is also theta. So theta, let us call this as theta. Theta is 2 by 2. 2 by 2 is 1. So I think it's 45 degrees. Right? Theta 1 is 45 degrees. And you have one more force here, 400 Newton, 400 Newton. So first you select the reference axis, x and y. Then find the sum of horizontal component. In this case, sigma f of x is 400 plus this one. That is, it is acting in the third quadrant, 45 degree, 600 cos 45. You can see sigma f of x is 400 plus 600. Again, he has done a mistake here. Okay. Here he has resolved with respect to y-axis. So either x-axis or y-axis because both is 45 degree. So he has resolved with respect to y-axis, or else directly you can take 400 plus 600 cos 45. 600 cos 45. So this is also 45 degree, right? And this angle is also 45 degree. So sigma f of y is 200 acting in the upward direction minus 600 sine 45. 600 sine 45. So now this is the values of sigma f of x and sigma f of y. So thereby we get the magnitude of the resultant, that is 854.228 Newton. And also you can find the direction of the resultant. It works out to be 15.22 degrees. Now you have to consider the moment of all the forces with respect to this point. Now since 200 Newton force is acting along y-axis, this coinciding with this point, so hence the moment becomes 0. Now this force 400 Newton is acting right over here, and the perpendicular distance is 40 millimeters. So you can see 400 This is 400. This is 400. Why he has taken 600? Okay. Anyway, this is instead of 400 is 40. Now you can see the printing mistake here. This is 400. The height is how much? Oh, it is 400 millimeters itself. So each one is 100. Okay, fine. So 400 into 400 plus this one 600 sine 45 into 400. 600 sine 45 into 400 millimeters. So thereby the sum of the moments is 329.76 Newton meter. So the unit of moment is always Newton meter, not Newton per meter. So be careful. So write the appropriate unit. It is 329.706 Newton meter. Now you can, in this problem, you are asked to find the magnitude and direction of the resultant and also the y-intercept of the resultant. So the y-intercept of the resultant is nothing but sigma m, whatever the moment that you have taken, that divided by sigma f of x. So it works out to be 0.4 meter. Now here, the sigma f of x is positive and sigma f of y is negative. So hence the resultant lies in the fourth quadrant and the angle made by the resultant with respect to x-axis is 15.22 degrees. Now again here you have one more problem here. So here it is a rectangular plate of dimension 700 millimeters by 375 millimeters, and here the I think three forces are acting here. One 600 Newton, and this is 500 Newton, and this is 340 Newton. So now you can find these angles, theta 2 and also these angles, that is theta 1 or theta 2. So you know this height, correct? So the tan theta, let us call this as theta. So this is with respect to y-axis, and this is with respect to y-axis, and this is with respect to x-axis. Now, say this is consider this triangle, right? This triangle. So find out this angle. Find out this angle. So tan theta 1. So let us call it as theta 1. Tan theta 1 is 200 divided by 375. So thereby you will get this angle, tan theta 1. So whatever the angle. So this is the angle made with respect to x-axis. So 90 minus of this. So you'll get this angle. So similarly, you can find this angle, correct? Theta 1. That is tan theta 1 is 500 divided by 375. You'll get this angle with respect to y-axis. So 90 minus of that will be the remaining angle with respect to x-axis. Now just find the values of theta 1 and theta 2. Tell me. So take this problem as a, you take the piece of paper and a calculator and find these angles, theta 1 and theta 2. Could you do this? So I think you consider this as theta 1, okay? So tan theta 1 is 200 divided by 375. Theta 1 is tan inverse 200 by 375. So tell me this angle. This angle and this angle. So you can see here, he has taken this as theta 1 and this as theta 2 and this as theta 3 and this as theta 4. Can anyone tell the angles, please?
Theta 1, 28.072.
With respect to y-axis or x-axis? You had taken this as theta 1, I hope. Okay. This is how much? That is theta 1, 500 divided by 375. Theta 1 is tan inverse 500 divided by 375. So tell me this angle with respect to y-axis. Because this becomes the opposite side and this is adjacent side. So you can find this angle theta 1. So theta 1 is tan inverse 500 divided by 375. How much it is? Could you please tell me? Anyone?
$53.1.
This angle is 53 point. How much?
53.130.
53.1. So this is the remaining angle is theta 2, 90 minus 53 point something. So it works out to be 37. 53 minus 90 minus 53 is I think 37. Correct? Theta 2. Hope so. Because this is 53. 90 minus 53 is theta 2 will be about 37. Or 36 point something 9. How much it is?
36.87.
Okay. Or else you can take 53. You can round it off to the nearest one. So if this is 53, the remaining angle will be 37. And what about this? Theta 2? It's 200 divided by 375. Theta 2 is tan inverse 200 by 375. How much it is?
28.072.
28.0. So you can take 28. So 90 minus 28 is, I think it is the remaining angle, this one, not this one. I think 68, 62.
61.927.
You can take it a round number. The calculation becomes. Anyway, the time is running out. So thank you for attending the class. So I'll continue the class tomorrow. So please mark your attendance. So please, I request all of you to mark only once because Tipperamma, are you there? Tipperamma. She has marked thrice in the last class. So it's my personal request. So please mark only once. Okay. So can you hear me? All of you.
Yes, sir.
Okay. I'll continue the class tomorrow. So till then, have a nice day. Stay safe. Goodbye. Thank you.